Isaac Newton was born into a world vastly different from the scientific landscape we know today. It was an era when the boundaries between science, philosophy, and mysticism were fluid, and when human understanding of the universe was still limited to ancient theories and interpretations. The scientific revolution of the 17th century was just beginning to take root, challenging centuries-old dogmas and sparking a newfound curiosity in natural phenomena. At this time, thinkers like Galileo Galilei and Johannes Kepler had made early strides in understanding the cosmos, challenging established beliefs and paving the way for the scientific method. However, many mysteries of the natural world remained unexplained. The forces that governed celestial bodies, the properties of light and matter, and even the principles of motion were topics of intense debate. Amidst this backdrop, Isaac Newton would emerge as one of the towering figures of science, whose work would not only build upon the achievements of his predecessors, but transform humanity's understanding of the universe in profound ways. Newton's life was one of relentless curiosity, solitary study, and an unyielding pursuit of knowledge. Despite a difficult childhood marked by personal loss and isolation, he possessed an intellectual brilliance that would lead him to the very forefront of scientific thought. His groundbreaking work in mathematics, physics, and optics laid the foundation for classical mechanics and transformed every field he touched. Newton's scientific achievements and publications fundamentally altered humanity's grasp of the universe, from the smallest particles of light to the vast orbits of planets. But Newton's genius was complex and multifaceted. He was not merely a scientist. He was also a deeply religious thinker, a scholar of the Bible, an alchemist, and a philosopher. This mixture of science and mysticism shaped his worldview and often left him at odds with the more empirically minded thinkers of his time. Newton's studies in theology, his fascination with alchemy, and his profound interest in the mysteries of existence reveal a man who was not content to simply observe the world. He sought to understand its hidden truths on every level. The story of Isaac Newton is one of extraordinary achievements and discoveries. It is a tale of ambition, rivalry, and resilience, a journey through the foundations of calculus, the principles of gravitation, and the nature of light itself. From the apple that supposedly inspired his theory of gravitation to his role in revolutionizing the English currency, Newton's life and work shaped the course of modern science and left a legacy that endures to this day. In examining Newton's life, we see the evolution of a man who transformed human thought, challenged the limits of his time, and laid the groundwork for the modern world. This is the story of Isaac Newton, the scientist, the philosopher, and the seeker of knowledge whose influence reaches far beyond the centuries. Early life, 1643 to 1661. Isaac Newton was born on January 4, 1643, in Woolsthorpe, Lincolnshire, England. He was born prematurely, and his father, a prosperous farmer, had died 3 months prior to his birth. Newton's mother remarried when he was 3, leaving him in the care of his maternal grandmother. This childhood separation deeply affected him and influenced his solitary and introspective personality. Newton showed early promise in academics. At the age of 12, he was sent to the King's School in Grantham, where he first displayed an interest in mechanics and engineering, creating sundials and models. In 1661, he enrolled at Trinity College, Cambridge, where he worked as a sizar, a student who received a scholarship in exchange for serving other students. Newton studied at Cambridge during a time of scientific revolution, with works by Galileo, Kepler, and Descartes influencing his early thinking. At Cambridge, he was introduced to the philosophy of Aristotle, but soon turned toward the works of modern thinkers. He also began studying mathematics, diving deeply into geometry, optics, and mechanics. His Annus Mirabilis, or Year of Miracles, was from 1665 to 1666. During this period, Newton made groundbreaking discoveries while at home in Woolsthorpe, where he had retreated to avoid the Great Plague. During this time, he developed his theories on calculus, optics, and gravitation. Calculus. Newton developed the foundation for calculus, which he called the method of fluxions. He used it to solve problems of motion and change, though he delayed publication, leading to later disputes with Leibniz over priority. Optics. Newton experimented with prisms, discovering that white light is composed of a spectrum of colors. His work in optics would lead to the invention of the reflecting telescope, a significant improvement over existing designs. While legend says he was inspired by a falling apple, Newton's observations led him to the idea of universal gravitation, explaining that the same force governs both the motion of planets and objects on Earth. Newton returned to Cambridge in 1667 and quickly became a Fellow of Trinity College. He was appointed Lucasian Professor of Mathematics in 1669, allowing him to focus on his studies. His work in optics culminated in his book Optics, published in 1704, which explored the nature of light and color. Newton's experiments with light led him to invent the reflecting telescope in 1668, which used a mirror instead of a lens to reduce chromatic aberration. This innovation allowed for clearer and more detailed observations, and the Royal Society, impressed by the telescope, elected him a Fellow in 1672. Newton's most significant publication, Philosophia Naturalis Principia Mathematica, often simply called the Principia, was published in 1687 with the support of Edmund Halley. The Principia presented Newton's three laws of motion. 1. Law of inertia. A body remains at rest or in uniform motion unless acted upon by a force. 2. Law of acceleration. Force is equal to the mass of an object times its acceleration, F = ma. 3. Law of action and reaction. For every action, there is an equal and opposite reaction. Newton also included his law of universal gravitation, asserting that every mass exerts an attractive force on every other mass. This law unified celestial and terrestrial mechanics, explaining both planetary orbits and falling objects. The Principia transformed scientific understanding and firmly established Newton as one of the foremost minds in science. In the 1690s, Newton became involved in a dispute with German philosopher Gottfried Wilhelm Leibniz over who had first invented calculus. Although both men developed it independently, the conflict intensified due to national pride and professional rivalry, with supporters on both sides defending their claims. The dispute lasted until Leibniz's death in 1716, tarnishing Newton's reputation and demonstrating his possessive and confrontational side. In 1696, Newton accepted a position as Warden of the Royal Mint, later becoming its master. He took his role seriously, overseeing England's currency and combating counterfeiting. Newton's rigorous work led to the introduction of a standardized, reliable currency, helping to stabilize the British economy. Newton was deeply religious but held unorthodox beliefs, rejecting the doctrine of the Trinity. He studied the Bible extensively, producing works on biblical prophecy and church history. In addition, Newton spent considerable time on alchemy, searching for the philosopher's stone and the secrets of nature. These studies, which were not widely known during his life, reveal Newton's interest in mystical and esoteric knowledge. Newton died on March 20, 1727, and was buried in Westminster Abbey, a rare honor for a scientist. His death marked the end of an era in scientific thought and the beginning of the Age of Enlightenment. Newton's work influenced generations of scientists and thinkers, from Leibniz and Euler to Einstein. Key contributions and legacy mathematics. Newton's calculus laid the foundation for modern mathematical analysis. Physics. His laws of motion and gravitation remain central to classical mechanics, which dominated physics until the 20th century. Optics. Newton's studies in optics influenced the development of the field, and his reflecting telescope remains a key innovation. Philosophy and methodology. Newton's empirical approach, focusing on observation, experimentation, and mathematics, set a standard for scientific inquiry. Summary. Isaac Newton's life and work redefined scientific inquiry and profoundly changed our understanding of the natural world. His mathematical and physical principles have stood the test of time, forming the foundation of classical mechanics. Newton remains a central figure in the history of science, and his contributions continue to inspire both scientific and philosophical thought.